Okay, students, so we're going to do absolute value graphs today. So we're going to graph absolute values using table of values. Whoops, not graphs. It should be graphs. Uh, so we're going to look at the graphs of y is equal to the absolute value of x, or f of x is equal to the absolute value of x. And we're going to show what it looks like as a negative as well. So you'll be able to graph absolute values at the end of this lesson. Okay, so let's slow down a bit and graph the function f of x is equal to the absolute value of x. Now again, we're using f of x here. You can think of this as my y value. It's better to think of it as your dependent variable. So this is my dependent and this is my independent. So this will be good practice for using f of x notation. So we're starting off with a little review of graphing this basic equation. F of x is equal to absolute value of x. And for my independent variable, I can pick any values here because it's independent. It's my inputs, and I'm going to see what my outputs are. So let's pick from -3 to 3. Okay, so I've picked those values. Now I'm going to evaluate and see what my f of x is for each one of those values. So using f of x notation, so f of -3, if I put a -3 here, is equal to absolute value of -3, which is simply 3, because that's what the absolute value does. So if I do that for all of my values here, for all of my independent variables, you can see that I get just positive values. Let's graph that and see what it looks like on a graph. Alright, well, this is the V shape that we studied before. So we have this V shape for absolute value. And if you look at that, notice that the graph is only in the first and second quadrant. It's only in the first and second. And that's because this is where my f of x value is positive. So you can see that f of x is positive here. In the first quadrant, same thing here. My f of x is positive up here. Well, down here we can't say that. My f of x is negative and negative down here. This is where the dependent becomes negative. Well, absolute value says we can't have in the negative, so that's why this stays in the upper quadrants. Now we'll see that we can have this graph come down into the negative quadrants, but we're going to have some values added onto this. So we'll see that in future examples. Let's look at this point here that's circled in red. Well, this point is right here in my table of values. And notice that my y's on this side, well, they come down and approach this point. And these values from this side, so as I'm going from the far right, I'm approaching this same point. So this point has a name, and the name of it is the vertex. So this is a very important term that you're going to see a lot through Algebra 2. So let's look at the word vertex. So if I look at the definition of vertex, well, right here it says vertex is the highest point, the top or the apex, the crown of the head. Well, this is how it's used in if you're reading a book and you read it in your English class. However, in math, we have a different definition, and it's where two rays meet. So we have at this point of these two rays. So we'll call this the vertex. So and notice that it doesn't have to be at the top. Right here we have the vertex not at the top. Alright, let's look at a more difficult problem. So if we have f of x minus 3 is equal to the absolute value of x minus 2, let's graph this. Now the first step is let's get this value that's attached to my dependent variable onto the other side and rewrite this. So this will isolate my f of x is equal to the absolute value of x minus 2 plus 3. So we're going to get rid of these scaffolding, put this right up here. Alright, so this is what we're trying to graph here, this f of x function. So let's come over here and draw a table. So I have my f of x table, and I'm going to pick values for my independent variable. I'm going to start off with -1. I'm going to go 0, 1, 2, 3, and we'll go on for a bit. So to 4, and let's do 5. Okay, so again, if I plug in to my x independent variable into my f of x, well, for this case, I would have f of -1, which is equal to absolute value of -1 minus 2 plus 3. That was just plugging that in. And if I simplify this or evaluate it, that's going to be equal to, well, -1 minus 2 is -3. But -3 in the absolute values is a +3, so I end up with a 6 right here. Now for all these values I can do the same thing, and I'll see that if I have a 0 instead here, 0 minus 2, that would be 2. 2 plus 3 is 5. For this one I would get a 4. For this one I would get a 3. And I would get a... Now when I come back down here, let's plug this one in and do the f of x notation. So f of 3, well, that equals 3 minus 2 plus 3. And if I look at that and evaluate it, that gives me, well, 3 minus 2 is 1. 1 plus 3, that puts me back up at 4. And when it's 4, I would get 5, and at 5 I get 6. So let's clean this up a bit. Alright, so if you look here, you can see a pattern. So my y's, as I'm approaching from the left, from -1 to the right, well, I'm approaching one number. And what number is that? I'm approaching the 3. So this is my vertex. So we're going to see that when we graph this, this is the point of inflection where it turns directions and reflects the other way. So let's go -1, 1, 2, 3, 4, 5, 6. Let's graph that. At 0, it's 1, 2, 3, 4, 5. At 1, 4, and you can see this linear relationship. 2, it's 3. And now at 3, we're going back up. At 4, it's 5, and at 5, it's 6. So we see that this has a very symmetrical shape. The dots are a little off, but I get this V shape, and it should be completely symmetrical. So I have this V, and it goes on forever to the left, and it goes over forever to the right. So I could say that my domain is all reals. Let's write that because that's a good review. My domain is all reals. All reals, because it goes forever to the right and forever to the left. Alright, on this one, let's look at if we have a negative sign in front of the absolute value. So our first step is, if we're given it in terms of f of x minus 3 is equal to a negative absolute value of x minus 2, let's rearrange this so that we just have our f of x by itself. So I have this negative sign in front of my absolute value. What's going to happen? Well, let's see what our table of graphs shows us. So again, with my independent variables, I'm just going to choose some, my inputs, and I'm going to see what my outputs are. Well, f of -1 would give me, if I evaluate that, gives me 0. When it's 0, I get 1. When it's 1, I get I get 2. And when it's 2, I get 3. When it's 3, I get 2. And notice what they're approaching. They're approaching this value here, 2, 3. So that is my vertex. So let's graph that. There's my vertex. Let's graph all these other points. And when I connect those, I get this graph. It's an absolute value graph. However, it's upside down. It's the vertex is now at the top, and the graph is going forever down. So if I look at the range on that, if we're saying that the graph is going down forever, my possible values for my dependent variable, well, it's everything less than or equal to all my possible values of my f of x, everything down here. So that's everything less than this vertex point, which is 3. So that would be my range for this. So again, notice that if we have a negative here, if we have this negative, well, my graph becomes an upside down V. Okay, so let's wrap this up with a few big ideas. The first one is that the dependent values approach the vertex. So that was, in this case, we have the dependent values, they approach the vertex. This one as well. So we'll get this vertex by seeing where those dependent values converge. Also, if there's a negative in front of the absolute value, then the vertex will be on top. We saw that right here, the vertex is on top. So when there's a negative in front of the absolute value. And if we look at the domain and range, the domain is always all reals, because it's always going to keep going forever to the left and forever to the right. So the domain is going to be all my possible values of x. You can have any input. My range, however, my range will never be all reals. And we can see that's because up here, look at this whole area. We cannot have our graph up in this region, so it'll never be all reals. It's going to be from some point, we'll have a greater than or equal to sign like this. And the range here, it's going to, for that would be f of x is greater than or equal to, and again that's 3. So it's everything above here, but we cannot equal any of this. Alright, I hope you guys feel confident in graphing absolute value equations.